Okay, let's have a look at an example, and this is going to use all these wonderful theorems. O is the center of the circle. Look at that, center of the circle through A, B, C, and D. Let's have a look at that. O is the center of the circle through A, B, C, and D. So obviously these are radii here. Look at that, those are radii and they're equal. Okay, and then what else do we know? We also see that it says there that BC is CD and BOD is 2x. So BOD is 2x and BC, this is equal to that. Okay, so we've got BC is equal to CD. So immediately, what can we conclude about the angles? We've got this angle is equal to this angle. D2 and B3 are equal. Isosceles triangle. Okay, which is great. And then if you brainstorm this, what else do you know? Do you notice the bow tie? We've got angle A being equal to D2 as well, because there's your arc BC. Look at that, there's an arc there, BC. It forms equal angles at the circumference. We've also got a center, so that the angle at the center could be twice the angle at the circumference, but we've just got to be very careful here. It's not quite as easy as it seems, because remember, you're going to be dealing with a very big arc here. Okay, so let's have a look. Let's see what the questions are. Okay, it says express the following in terms of x, and we want to focus on B2 there. Okay, so let's have a look at B2. Alright, no problem. If you look at this, these are equal. Okay, these, in other words, this angle here is equal to that angle there. It's the angles opposite the equal radii. Now that's 2x. Now watch this. If you take angle O, I'm just going to go down a little bit here. If you look at O, okay, this is number A now. If you look at O, angle O, which is 2x plus B2 plus D1, what do you know? It's 180 degrees. That's because of the sum of the angles of a triangle. Okay, the sum of the angles of the triangle, they add up to these guys. Now, if you think of it, B2 is equal to D1, but what do we want to find? Okay, we want to find B2 here. Okay, that's what we want to find. Okay, well, if you think about it, B2 is equal to D1, so we could say O is 2x. We want to find D1, okay, or what's it B? Well, what's it there? B2. So we want to find B2. So let's leave B2. But what do you know about D1? D1 is equal to B2. And because that is what we can say, the fact that B1 is equal to B2, or D1 is equal to B2, and the reason for this is going to be angles opposite the equal radii. Can you see that there? Angles opposite the equal radii. So obviously D1 is equal to B2. That's because D1 is equal to B2. No problem. So now we've got 2x plus B2 is 2B2, okay, is equal to 180 degrees. And what I think I'm going to do, which would be quite cool, let's divide everybody by 2. So we get x plus B2 is 90. So B2 would be 90 minus x. That's B2 expressed in terms of x. Okay, look at that. So in other words, what we can do is we can say that B2 is 90 minus x. And what is D1? 90 minus x. Now add them up. 90 plus 90 is 180. Negative x minus x is negative 2x plus this 2x cancels, giving 180. The sum of the angles of a triangle would be 180 degrees. Now look at that. Isn't that amazing? So you simply use the sum of the angles of a triangle. 2x plus B2 plus D1 is 180 degrees. Okay, but then what do we know? We know that D1 and B2 are equal. Why? Angles opposite equal sides. D1 is equal to B2 there. We've got it there. Those two are equal. Angles opposite equal sides. And then, of course, all you need to do is you can see that you change the D1 to B2. So there's two of those giving you 2B2. 2x comes from the fact that angle O is 2x. And then you divide everybody by 2. x plus b2 is 90, so b2 is 90 minus x. Okay, now what's the next one? Okay, now let's look at BCD. Okay, what about BCD? Okay, where is that there? Okay, that's this angle C1 plus C2, this angle here. We're interested in what it is. Now, if you think about it, the angle at the center here is twice the angle at that circle. There's a big arc that's happening here. So what do we know? Now, we're careful. To get this angle, that's the same as saying 360 minus 2x. Okay, angles around the point. Okay, and then the angle at the center is going to be half the angle, or twice the angle at the circumference. So if this is 360 minus 2x, this angle C1 plus C2 must be 180 degrees minus x. The angle at the center is twice that. So let's write that into good mathematical language here, B. What we can say is that the angle BOD, and that's a reflex angle. Okay, remember, bigger than 180 degrees. Okay, and that's going to be equal to 360 minus the 2x, because that's angles around a point. Okay, so if you want to put a reason there, this is angles round a point. Okay, cool. Now, if you think of this, we've got that. Now we can say that's the angle C, BCD there. Okay, or you can think about it as you can say that BOD reflex is equal to, so BOD, that reflex angle, is twice the angle at the circumference. Okay, but you've already worked out BOD, which is that is equal to 2c, so then angle C is 180 degrees minus x. That is C in terms of x there. You've expressed C in terms of x as they wanted. Okay, and that's BCD there. This is the angle BCD, if you think about it. Let's go up to the diagram. So BCD is C1. Remember, C1 plus C2 is in fact BCD, and that's double that. So if that's 360 minus 2x, then that angle BCD, C1 plus C2, is half of that. And remember, this is not a cyclic quad, OBCD, because all four corners don't lie on the circumference. O is at the center. So you have to go angle at center is twice the angle at the circle there. Okay, what's the last one? Angle A. Well, that's pretty easy. We've got D2 is equal to A, so we know that. We also this is 180 degrees minus x, and those two are equal. So what I'm going to do is I'm going to use the sum of the angles of a triangle. Now watch this. I'm going to write down this and then go back there. You would probably agree with me that B3 plus D2 plus C1 plus C2 is equal to 180 degrees. That's sum of the angles of the triangle. Let's just go back to the diagram. B3 plus D2, this one, plus C1 plus C2 is 180 degrees. But of course, C1 plus C2 is 180 minus x. So we can go here and say, well, okay, we also know that B3 is equal to D2. That's angles opposite equal sides. Okay, watch that. So these two guys are equal here. B3 is D2. There we go, B3 is equal to D2. So, and remember, we're trying to find angle A. Okay, so that's a very interesting thing. So we really want, if we can get D2, that'll be pretty cool. So let's have a look. Let's continue with this argument. And then we also know, so we can say, well, okay, and then C1 plus C2, that guy's 180 minus x. So then we've got B3, and we want to get to D2. So I've got B3. I'm going to change this B3 to D2, so it's D2. That D2 can stay. Then we've got C1 plus C2, which is 180 minus x, and that equals, of course, 180 degrees. Okay, great. Okay, now let's have a look. I want you to look at this. This gives you 2D2 plus the 180 degrees cancel. And if you look at that, we can just remove the plus there, and then we've got that negative x going to the other side, becoming x there. And then what does that tell us there? We simply can say then D2 is equal to x over 2, a half x. Okay, so if then d2 is equal to a half x, then what do we know about angle A? So if this here is a half x, so d2 is a half x, what do you know about d and a2? d2 is equal to a, angles in the same segment. Look at the bow tie there. See that there? There it is, that little butterfly. So a is equal to we can say a is equal to d2. Now watch this here. So we can say, but a is equal to d2. That's angles in the same segment, if you like. And there we go, angles in the same segment. And therefore, we can say that that angle A is also going to be a half x. You've expressed it in terms of x, angle A. So all of these angles have been expressed in terms of x.